In this video, I'm going to go over how to implement a binary search in C++. A binary search splits a sorted data set into an upper half and a lower half, then searches the half that the value the user is seeking would be found in, based on whether the target value is higher or lower than the middle value. The halves keep getting split into smaller halves, until eventually the data set is narrowed down to the number you're looking for. So for example, if you have a set of n numbers, instead of making n comparisons, a binary search only requires log base 2 of n comparisons. For 8 numbers, a binary search can be done in 3 comparisons instead of 8. To be even more efficient, we're going to make this binary search recursive. This is a really good example for anyone who is trying to learn about recursion and data structures. You want to start by creating a new project in whatever IDE you prefer. I'll be using Microsoft Visual Studio. Once you have that project made, we're ready to go. std.afx has already been included for us. We're also going to be using the IOStream header file so we can talk to the user. And we'll also include another built-in header file called vector. More on that in a minute. Don't forget to add using namespace std so that the compiler recognizes your C++ commands. Now we can set up our main function. We need to initialize 4 variables to begin with: a vector and 3 integers. You can customize the user interface for this program however you want, especially if you have a specific application in mind for this program. We want to find out from the user how many numbers are in the dataset, then get those values. In this case, the user will just put in the list every time, but you could change this to read the numbers from a file. Then push the values into an array using the vector, which essentially works like the stack. Now we need to find out what number the user is looking for. Hopefully it's in their dataset, but if not, we'll handle that too. Now that everything is set up to get input from the user, it's time to write the portion of the code that performs the search and displays the results. The name I'm giving this function is binary search. The inputs are vec, which is a pointer to the vector that the user input of the sorted list of numbers, start, which is the first index of the list, end, which is the last index of the list, and val, the value that the user is searching for. First, we'll set up a variable called mid. This finds the middle index of the list array. It's half of the length of the list, offset by the first index. Now access the middle of the list and compare it to that value. This is where recursive calls come in. If the middle value happens to be the value the user is searching for, simply return the middle index. This is the base case. If the middle value is less than the search value, search the upper half of the list. If the middle value is greater than the search value, search the lower half. We'll fill in the code for these sections momentarily. In each of these cases, make a recursive call to the binary search function. In the first one, make the starting index middle plus 1 and the ending index the end of the array. For the lower half, make the starting index start and the ending index 1 less than mid. Finally, you need a conditional statement that will allow the program to exit the function if the search value is not found. This happens when the half array is down to one number and start is equal to mid. This actually needs to happen at the beginning of the function because of the recursive calls. Now our binary search function is done and we can test it out. Going back to the main function, initialize a new integer variable. After the portion of the code where you get the input from the user, call the binary search function and assign the returned value to loc. Remember that when we set up the function, -1 meant the value was not found. Any other number returned is an array index. Remember that you can format these output statements however you want, or you can use the results of the search for another portion of a larger program that has more features. Finally, I'm adding system pause at the end so I can run this in Visual Studio's debugger. Now let's test it out. And now you can perform a recursive binary search.